Alright, so I'll be solving Palindrome Linked List, and let's get right to it. So assume that, let's zoom in a bit. Okay, assume that we have this kind of head. So 1, 2, 3, 3, 2, 1. This obviously is a palindrome, but how do we code it? Well, linked lists are very different from like regular arrays. We don't know the size of linked lists basically. So what we have to do to find the size, or basically do anything with linked list, is use 2 pointers for this scenario. So we're going to use 2 pointers that start at the head, but one goes twice as fast as the other. So let's say slow and fast both start at 1, but slow will just go one at a time, but fast will go twice as fast. So, well, slow. Okay, so you get the idea. Fast will go twice here, and fast goes here, and when fast reaches null, well, then we know that slow is gonna be at here, at this step, and fast is gonna be at null here. So basically our slow pointer is effectively at the middle of our linked list, which we want. And then what we have to do is reverse this linked list so that our slow pointer is at 1. And we move our fast pointer here at the head again, and our slow pointer to the 1. And then we kind of merge it together, and if the values are the same, then we move this fast and slow, and if it's same, we move the fast and slow. You get the idea. Okay, so let's code it. Okay, so as I've said, we want to make 2 pointers. List node start equals head. Wait, why is so much missing? Oops, I accidentally deleted the method. Okay, so this should be given. Oh, okay, and inside this method we want to create local variables, not instance variables. So, and fast equals head. Okay. So we have our 2 pointers, and it's all at the head, so at 1. And we want to check if fast is not equal to null, or where's end? Fast.next is not equal to null. So this is the end condition where it goes beyond our head. So right here, until here is fine, but if it goes like beyond, then we don't want that. Then we traverse slow equals slow dot next. So moving slow here, right, and at 2, and fast is going to be here. Fast equals fast dot next. So maybe you don't really understand, so let's go step by step. So this runs perfectly fine, and no. And next iteration, s is going to be at 3, and fast is going to be at 2, right? That's fine. And fast is not equal to null, and fast.next is not equal to null, right? It's value 1. So we do that array again, and f is at null, so we stop this iteration. So that's when we know. But what if we have an odd number of odd number of elements, like 1, 2, 3, 2, 1? Then if s and f starts at the start, the s will here, f will be here. Okay, and if we run it one more time, slow is going to be here, but fast is not going to be null. It's actually going to be at 1, and this iteration stops. So if fast is not equal to null, this means that it's odd number of elements inside. Oops. So we move this slow pointer one more step to 2, because we don't really have to worry about this middle point, right? Slow equals slow dot next. Okay, I hope you guys understand through my example, and let's make slow move. Let's create a reverse function that moves our slow pointer so that it's like slow is going to be at this 1. So let's make that private list node reverse list node. Let's say head, because by default, like here, head is our slow pointer is at the head of this perfectly divided by 2 a linked list. So you guys know, like when we substitute values, of a and b, like we create a temporary variable called like temp, and then we store the the value b inside temp, and then we do like kind of substitution. So that's basically what we're gonna do. So list node, let's say tail equals null. That our tail is gonna be that temporary value, and we're gonna do, well, head is not equal to null. That's the end condition. Okay, so let's go here. Where's our example? Okay, so head is here, and we've created like a random node called this. So it has value 3 and tail is null. So we want, and our linked list is pointing in this direction, right? But what we want is like this, 2 pointing like 3, right? And reverse it again, we want this. Basically we want to reverse this to this. So let's start from this. So head, we know that we're going to store this value, this next value. So let's say list node like proof equals head dot next. That's storing the value too. Let's just say next. Yeah, next is more intuitive. So that value next is storing the value too. Now we actually want to connect our head not to this next, but to our tail, to substitute value of 2 inside here. 2 inside here, and head's value inside our tail. So wait a minute. So what I mean is that so head dot next is going to point towards our tail. Now originally it's pointing towards next, right? Like here, 3 is pointing towards 2, 3 is pointing towards 2. But what we do now is we sever this connection, and our head is going to point towards our tail here. So there's no connection here, like no connection here. We point it towards our tail. So that's like basically half of the job done. And from here it's really easy. We substitute value of 3 inside our tail. So tail is going to be storing the value of 3. So this is going to be 3. And our heads has to be changed to 2, right? Because we want like this. So head is going to be the value of next. And we do that, and we return tail. So tail will be here. Okay. And And once you've reversed this slow, we want to go with while fast, or maybe like it doesn't really matter, but while slow is not equal to null. Okay, what we do is, oh, by the way, we want to move this pointer, this fast pointer to head, right? So let me copy this 3, 2, 1 again. Oh, actually, I have to copy this entire thing. 1, 2, 3, 1, 2, 3. So our fast pointer is here, slow pointer is here. Okay. If fast.value is not equal to slow.val, then that's when we know it's not a palindrome. If not, we move the pointers towards together. So fast equals fast.next. And if all this passes, we return true. So let's see. Oh wait, it's start. Freaking hell. I was wondering why. Okay. Sorry for that. And submit. Okay. Oh. Yep, so I misspelled it. It's slow. Yep, so that's basically it. And I'll see you guys next time. Bye.